Hello there. Another publicly available AP Physics 1 question. This one is for forces and uniform circular motion. We have two weights. One M1 is on frictionless surface and it's rotating at a constant speed with a period t, constant radius r. What is keeping it rotating? There is a mass 2 that is hanging off of the string, so they're connected with a string. They're in equilibrium. The M2 has gravity on it, so M2G, and tension, and they're equal because M2 is at rest. M1 has M1G supported by normal force, and the centripetal force is that force of tension, which is identical here. Force centripetal, which is M1 V squared divided by r, should be equal to M2G. So from there, if I were to figure out V squared, that would be M2G times r divided by M1. V, on the other hand, is 2 pi r divided by period of rotation. Period of rotation is going to be 2 pi r divided by V. So V, if I root this, is the root of this equation. So then period is 2 pi. I'm going to put r over here. Then it's going to be root of M2G times r. And then M1 with a root comes upstairs. So that altogether boils down to 2 pi, and then we have a root, and we'll put everything under it. We will have r, this r, and this will become M1r over M2G. They want it written as such, M1, because the radius is that little r, M2G. Voila! In the next part of the question, we are asked to graph a set of data that was obtained through an experiment where they were changing the mass, and that was changing the period of rotation with the same radius and the same mass 1. So remember how we derived this lovely formula for period? M2 was changed, so that is one of the variables, and period changed due to that. So if you look at the formula, we have the connection between period and M2. You have options, you have 4 at least. We could do t versus 1 over root M2, and then the slope is going to be that. Another option, t squared versus just 1 over m. In that case, the slope would become 4 pi squared m1r over g. And that way, once I find the slope, I can just divide 4 pi squared m1r by slope, and that would give me my g. Yet another option, I could flip-flop this formula as a root of m2 would be equal to 2 pi root of m1r divided by root of g times 1 over t. And I could do root of m2 versus 1 over t. And we could also just graph m without the square root, but then we would do 1 over t squared. Those are all our options. And I went ahead and recalculated for 3. If I'm graphing t versus 1 over a root of m2, that was the graph. I got the slope to be 0.18, and that gave me 11.7 meters per second. A little harsh. I also did that for this versus just 1 over m. That gave me 10.2, a little bit better. And then I didn't do both of the other two. I just did doing 1 over t squared for these. That gave me the best value yet. Closer. If you have any questions, put them in the comments below. If this was helpful, please like, subscribe, be kind.